Let's see how many times I'm going to say the phrase Google coding interview in this 2-minute intro. What's up, everybody? How's it going? We are all in dire need of a Google coding interview. It has been far too long since I've made a Google coding interview, and so in this video, that's what we're doing, a Google coding interview. But this Google coding interview is unlike a lot of my previous Google coding interviews on this channel. I am not doing this Google coding interview with an international grandmaster at competitive programming. I'm not doing this Google coding interview with someone who's won a medal in the International Olympiad of Informatics. No, this Google coding interview is with a normal software engineer because a lot of you commented in the previous Google coding interview videos that you wanted to see perhaps a more realistic performance in a Google coding interview, and so this is just that. I'm joined by Keerti. She's a software engineer based in India. As far as I know, she is not an elite level international grandmaster competitive programmer, hasn't won medals in the International Olympiad of Informatics, and so this is going to be a realistic Google coding interview. We did this Google coding interview on a Google Doc because that's how coding interviews are done at Google, especially right now. Even on-sites are virtual, so they're done on a Google Doc. And the question that I asked Keerti is a very hard question that we have on AlgoExpert. By the way, if you're preparing for your coding interviews and you want to get a job at Google or at any other big tech company, then go check out my company, AlgoExpert. Go to algoexpert.io and use the promo code CLEM, C-L-E-M, for a discount on the platform. We've helped tons of software engineers land jobs at Google and all other big tech companies and startups. And this question is actually a question that I have asked myself at Google in a real interview about a year or 2 years ago. And last thing before we jump into the interview, we actually did a second Google coding interview on Keerti's channel. She's got a channel where she talks about software engineering and coding interviews, so go show her some love and check that out after you finish watching this Google coding interview. I will put the link to that Google coding interview in the description and in the comments below. And with that, enjoy the Google coding interview. So, how many times did I say Google coding interview? Oh, and try to solve the problem as you watch the video and comment down below how you would solve it. Oh, and in the last 10 minutes of the video, we did a feedback session to cover Keerti's performance, so you don't want to miss that. Hi Keerti, how's it going? Are you excited for this interview?
I'm very excited and very nervous.
Okay, well, try not to be nervous, or try to let the nerves fuel you into acing this interview. And I'm going to put the timer on the clock now. We're going to have about 45 minutes, and I'll let you know, when we're running out of time or if we have to speeden things up, okay?
Sure.
All right, starting the clock now. So, Keerti, I want you to imagine that you are about to move. So maybe you're moving to a new location, and you want to find an apartment that you want to live in. So imagine that you have one street, and the street, you can imagine that it's on a single line. So imagine, a single line here. I'm just typing a bunch of ones to show that it's a single file line. And at each block in this line, there's an apartment. So you can imagine that I'm probably going to give you a list of blocks, street blocks, and at each block or each index, there's an apartment that you might want to consider living in. Are you following me so far?
Yeah.
Okay, so you want to make sure that the apartment you live in is really good for you. And the way that you're going to determine if it's good for you is if the apartment is close to some buildings that you really value. So for example, you really value, or you might really value, being close to a gym, or being close to the office, or being close to the supermarket. Does that make sense?
Yeah.
And so I'm going to give you information about, at each block, whether or not there's a building, like an office, or like a school or a gym, and you're going to want to find the apartment that minimizes the farthest distance that you would have to walk to get to all the buildings that you value. So I realize that I've given you a lot of information. I'm going to show you a couple sample inputs just so that you get an idea. So imagine the first sample input is going to be called blocks, and it's going to be a list, let me put it like this, that has a bunch of objects, hash tables, so to speak. And these objects have all of these buildings that map to Booleans. So here at index 0, you can see that there's a gym that maps to false, meaning that at block 0, there is no gym, but there is a school, but there is no store. At block 1, there is a gym, there is no school, and there is no store. Does that make sense?
Yeah.
Okay, and so then the second input that I'm going to give you is going to be a list of required buildings. So if I go a little bit lower here, I'll put rex, requires, or requirements. And this is going to be a list of strings. And this list of strings is going to have the buildings that you value. So here, you happen to value gym, school, and store. But I could maybe give you just like gym and school, or I could give you just gym, right? It could be any buildings, and they don't necessarily have to be in these objects. And so here, if you value gym, school, and store, that means that you have to find the block that has an apartment. And by the way, every block has an apartment. The apartments are kind of implied to be at every block. You have to find the block that will minimize the farthest distance that you would have to go to reach all of your requirements. And so here for this sample input, the answer would be index 3, which would be this one. If you want, I can highlight it, let's say in light green here, this one, because for this one, the farthest that you have to walk to get to all your required buildings, the gym, the school, and the store, is a distance of 1, because the school is right here, then a gym is 1 above, and then a store is 1 below.
Okay. Okay. So can there be only 3 things, that is gym, school, and store, or there can be more number of things?
There can be any number of buildings, and the only thing is that in the blocks, at each block, you will have information about every single building. So for example, if I were to add here something like, I don't know, office, then you could expect that every block would have a data point about an office, whether it's true or false.
Okay. And it will be a valid input, so I don't have to check whether all 4 are present or not, right?
Yeah, you don't have to check whether all 4 are present.
Okay.
They will always be present.
Okay. Okay. So at the top of my head, if I have to talk about brute force solution, so I can consider each block to be my solution, and I can just keep calculating the distance from them, right?
Okay.
So suppose I consider that my apartment will be here. So if like in this case, I can see that there can be multiple things in an apartment. There can be a gym as well as a school, right?
Yep.
Yeah. So the distance will be 0 plus 0, like that. So I will keep calculating the minimum distance as I traverse the array, and wherever I find the minimum one, I can just return that.
Okay. And just, can you walk me through conceptually, like how exactly do you find the minimum distance?
Okay. So suppose the requirement was just gym and school. Okay. So I come over here. Okay. I have the number of variables that are there in requirements. So same number of variables. So right now I'm going to keep 2 variables. That is the distance for the minimum distance for gym as well as the minimum distance for school. And there will be a result that I will store. That will be the minimum of sum of both of them, right? That is my minimum result that is possible. So when I am here, so I will have 3 variables. So one will be distance from gym. So gym distance. Then there will be school distance, and there will be resultant, that this will have the minimum value. Okay. So here, since this is false, my school distance will become 1, and this initially will be some maximum value. Say we take infinity or int max, and so this is infinity and this is 0, right? Then I come over here.
Okay.
Here gym is here gym is true, so here the gym distance becomes 0. So school, since I have traveled 1 distance, so it will become sort of the resultant from the previous one plus 1, right? So it will be distance of this plus 1, and then I will keep checking whether the resultant has to be updated or not, right? So the earlier result was max because it was not possible to reach gem at all. Here, so at every point I am just seeing the blocks before and not the blocks after that. Right. So I will traverse the entire thing once and then check. So, but it is also possible that the minimum can be from my right end, right? Like instead of from my left end, it can be from right end as well. So probably what I should do is traverse the array twice, one from the left side and one from the right side, and then check that what is the answer.
And just before you keep walking down that path, Keerti, just to be clear, you are looking for the minimal farthest distance that you would have to walk to, right? Because, so for example, like at index 3 here, which was the answer here, the farthest distance that you would have to walk to was still 1. Even though there was a school here, which was 0, you would have to walk 1 to get to the gym up here and 1 to get to the store down here. Does that make sense?
Can you please repeat that point?
Yeah, so since you have multiple requirements, or you might have multiple requirements, you want to minimize the farthest distance or the greatest distance that you would have to walk to. Because here, if you care about gym, school, and store, school is 0 distance from this index, right?
Okay.
But gym, you have to walk 1 to go up here. And store, you have to walk down 1 to find it here. So the point that I'm trying to make, that I just want to make sure you're clear with, is that it's the farthest distance that you have to go to that you're minimizing, not just any distance.
Okay, so it is not, so, okay, I understood it wrong. I understood that it was the sum of the distances. It is not like that. It is like farthest for any one that I have to go, right?
Yes, exactly. It's not the sum. So even though the sum here is like, I guess 2, it's not that we care about. It's the farthest that you would have to go to.
Okay, so it will be like, so I will have to minimize the max of gym distance and school distance essentially.
Yes.
Yeah. Okay.
That's one way to put it.
Yeah. So I have to minimize the maximum value among the requirements. Does that sound fine?
Yep, I think that sounds good.
So basically I will have I can have a hash map sort of thing, an ordered map. So corresponding to each requirement, I will keep the maximum distance, right? So, and I will minimize that. Okay, so corresponding, so, okay, I have to keep that. Okay, so for the entire array, just give me a second. For the entire array, for each block, I need to minimize the maximum distance. So for this, suppose I have to calculate the maximum distance, I will have to, so that will become order of n square. So now brute force will become order of n square. So if I have to, for this block, I will have to check the maximum distance from all the other blocks, right? Similarly, for this block, I will have to check for all the other blocks. So to minimize that, to make it order of n, I will have to use dynamic programming and store the values in a array. So if I have, say, dp array of distances, so this will again be it will be sort of array of vectors. So, and vectors will be the distances, the max distances for each of the requirements.
Okay.
Right. So, it will be like, so suppose there are n blocks, right? So, this dp, this auto, this thing, I'm not really caring about it, okay?
Okay.
Yeah, this caps lock. So I'll keep a dp array of size n, suppose, okay, and each of them is a vector. So it will be vector of vector of integers, say dp, and the entire size will be n, and each vector will be of the size, what will be the size of requirements, okay, say that is n in this case, and we will initialize the whole thing to some maximum value. Does this look fine?
Okay.
Right. So now as I traverse, can I just start writing the pseudocode and then we'll keep discussing?
If you want, but just to make sure I follow you, could you re-walk me through like what the logic you're about to write in pseudocode is?
Okay. So this is the array of vectors that I'm storing, right? So as I traverse this array, for each point I'm going to keep calculating, and like I will see all the answers previous to it and update it. So if like the maximum distance of this school should be the maximum distance of the previous one plus 1 if it is not present over here, right?
Okay.
So it basically, I am calculating maximum distance for each requirement for each block in the array.
Yeah.
Does that sound fine?
Yeah. But how are you doing? You said you're doing that in one iteration?
It will take 2 iterations, I think. So one will be, I'll go from left to right, and one will be from right to left.
I see. Okay.
Does that sound fine? And I'll take minimum of both.
Yeah, I think I'm following you. So if you want, you can write the pseudocode that you were going to write.
Okay. So I'll just write it in simple terms. So I equal to 0, I less than n, I plus plus. Okay. So I'm traversing the entire array right now, and for each element I have to track for all the requirements, right? So for int j equal to 0, so j less than m is the size of the requirements over here, right?
Yeah.
J plus plus, and so what I'll do is, if it is the first one, so for the first one I will update over here. So I'll traverse this from I equal to 1. Also, can I assume that there will be at least one element, or should I handle cases when there's just one block or 2 blocks?
Let's assume that there's always, let's assume, for simplicity, that there's always at least one requirement and one block.
Yeah. Okay. So in that case, for int j equal to 0. So this is for my first block. Okay. So for first block, as I go through this, so if these are the blocks given to me, so if blocks of 0, that is the first block that I am seeing, if the elements, so I'm just saying it. So can we say the input is given in terms of requirements? So 0, 1, 2, or should I save this thing, like should I pre-process this thing and save it in a array sort of thing? So basically what I'm trying to say is that for block 0, this is requirement 0, this is requirement 1, this is requirement 2.
I see. I had the requirements as a vector, a string vector, but if this is simpler for you, you can assume that you've pre-processed it to map the requirements to numbers if that's easier for you.
So would you rather have me write the pre-processing code as well, or is it okay to go like this?
For now, let's assume that you've written it. So just to understand, you're saying that basically your requirements now look like this.
Right. And
right.
here
okay.
I can just map it to 0, 1, 2.
Yeah.
It will.
And I'm assuming that you would do the same for the blocks, like the unordered map. Yes. Here, the keys in the unordered map.
Yes. So this will be an integer, and this will be a boolean. So boolean and integer.
Okay.
That's fine.
Yeah. Let's go with that for now.
Okay. So if my first block has this requirement, jth requirement, then what I do is I update that distance. So dp of so otherwise it will be int max, right? So otherwise so for this one I update dp of 0 j to 0. So the distance is 0 for this one. Okay.
Okay.
Does this seem fine to you till now? So this is for the first block.
Yeah, so you've only done it for the first block.
Yes. So for the rest of the blocks, so I'm starting from I equal to 1, I less than n, sorry. So here, so for rest of the blocks, what I'm doing is, so dp of any ith block, and for each j, what I'm going to do is, it will be equal to, so I have to find the maximum, the farthest that I have to go, right? So it will be, so the farthest that I have to go. So if, first of all, I will check if that one is true. So if blocks of ij, that means if it is present over there itself, then I can just assign the dp of ij to 0. That means that thing is present over there. If it is not present, what I do is I check if it was present somewhere earlier, right? So for this, so what was the distance for the previous one? +1 it will be, right? Now it is possible that we haven't found the previous one, so the value will be int max over there. So if I add +1, it will go out of bound, right? So I will have to add a check over here that if dp of I minus 1j is not equal to int max, right, then my dp of ij will be equal to, so minimum of whatever is the value. So if it is max now, so I don't have to consider it, or if it is 0, then okay. So minimum of dp of I minus 1j +1. Does this seem fine?
Yeah.
Yeah. So this is for, this is why when I'm going left to right, right? So for each of them, I am updating that what is the maximum distance that you have to go, right? Now with this, instead of doing this, I can do one more thing. So I keep this as m plus 1 instead of m. So the last element that I'm going to store will be the it will be the minimum of all these values. So this is like the maximum distance that I have to go, right? So I have to minimize the farthest distance that I have to go from all the blocks, right? So for each block I have to find that. So for each dp of I, basically I'm storing one more element which will essentially be maximum of all of these distances for that block, right? So when I'm calculating this, so for each of them, right? So where is this ending? Yeah. So after each this, so dp of, instead of this, yeah, over here I can add, so dp of I m will be equal to maximum of so initially it will be okay, so for each of them I have to add dp of im as some 0, right? So we can assume that at least so I have to find the maximum distance, right? So if that value is maximum initially only, then anyway it will always be max, right? The answer will always end up being max. So I initialize dp of im as 0, and I'll make this as dp of im and dp of ij. So whatever value I have calculated, if that value is greater, then I have to add it. So I'm storing the maximum value over here. Does this make sense?
Yes. Yep. You're updating at each iteration the maximum min distance of a requirement that you've found.
Exactly. Right?
Okay.
So I have done this when I'm going from left to right, but the maximum farthest distance can also be from right to left, right?
Yep.
So I will have to do the whole thing, like the same code I have to run in the other direction as well.
Right.
Right. So now what I do is, now for int I equal to n minus 1, I greater than equal to 0. So I can just copy this whole thing and make some small changes.
Yep.
Right, so dp of im, I don't have to update it to 0 now because some value is already there. I don't want to discard the value, right?
Right.
So now again for each block, I'll check. So this will remain same. Now instead of I minus 1, I'll make it I plus 1. And instead of n minus 1, I'll go from n minus 2. And it should be greater than or equal to 0. And it will be max of this. So yeah, I think this should work. Can I dry run and check?
I'm sorry?
Can I just dry run once and check? Or do you have any questions, or does this seem fine?
Yeah, I was going to say, could you walk me through, like, let's take the sample input that we have above with gym, school, and store, and we can assume that, I guess, gym is 0, school is 1, and store is 2.
Right.
And walk me through the algorithm, like basically iteration by iteration, just to see that it works conceptually.
Right. So I'll just store the DP values over here, right? Okay. So DP, so for like 0th value, what will be the values initially? If so instead of writing int max, I'm just going to write some big number, 100 for now, right? So that will be easier to understand. Okay.
Yeah, or if you want, you can even put like just like an asterisk or like a single character like this.
Yeah. Okay. So for DP of 0, so first we'll go through this one. So only for school it will be true. So it will be something like asterisk 0 asterisk, and the last value will be asterisk itself. Okay.
Because the last value, you take the maximum of all three of these.
Yeah.
Okay.
Okay. So also, okay, so here this is the tricky part. I haven't taken care of resultant, which will be the maximum of all of these DP of IM essentially. So we can calculate that. Okay, just let's first see if the rest is working or not. So DP of I1. Yeah, so I come over here, I put DP of IM as 0, which is okay. So for each block, I check if it is true, okay, otherwise I'll add the distance, okay. So here, since this is true, this distance is going to be 0, right? Now this is false, so this will be either int max or this plus 1. So this is going to be 1, and the distance of store is going to be this plus 1. So here, since it was max only, I'm going to keep it max, and dp of im is going to be max of these all. So since this is asterisk, so this will also be asterisk. So the maximum distance is infinity itself right now.
And just Keerti, just to stop you for 1 second, just to make sure that we're on the same page. So here you're effectively applying this line, right? I just copied the line that you had written.
Yes.
Right? And so at the second element, you took the minimum at that element, which was int max, and dp of I minus 1 at j, which was this 0 here.
Yes.
Plus 1.
Yes. So 0.
And the minimum was 1. Yeah.
Yeah. Okay.
So it was min of int max and 0 plus 1.
Yes.
Okay. That makes sense.
Yeah. So now coming to the second element. So if I am here, so here the values are going to be, since this is true, it is going to be 0, and this is also true, so it will be 0, and since this is false, it will be minimum of either int max or int max plus 1. Since this is int max, so again the value is maximum only, so this will again not get updated because the farthest distance till now is still infinity, right? Now if I come over here, it will be, so here the gem is false, so it will be either 0 or it will be either int max or 0 plus 1. So in this case it will be 1. Here it is true, so school is true, and store is again false, so this is again infinity, infinity. Okay, so
Yep.
for 4 again, so this is false, so it will max distance will be 2. Here it will be 0, so store is, wait, so 0, 0, 1, 2, 3, 4. Okay, so here this is true, so what I'm going to do is this will finally become 0, and our dp of im will be equal to max of dp of im and dp of ij. So what is the maximum value of all of this? Oh, sorry. Yeah, what is the maximum value of all of this? It is 2, right? So the farthest distance for all of this is 2 in this case.
Yeah.
Right?
And this is this line, just again to make sure that we're on the same page. It's this line. So you're saying dp of I, which is index 4 at m, is this value is the maximum of dp of I of m, which was int max, because you've initialized it to int max.
Correct. Yeah.
Yeah. And then, oh yeah, because you've initialized every single value to int max. Is that what this does here?
No, but I also initialized dp of im to 0, right? So this value
Oh, right.
was
You initialize it to 0 down here.
Yeah.
Okay. So max of 0, so max of 0 and dp of I of j, which would be, like basically at every iteration you would do max of 0, 2, max of 2, 0, 2, 0, and you end up with 2, right?
Yes.
Okay.
So in the second iteration, so this answer will remain same, and I'm going to start from n minus 2, which is this one. Okay, so I start from here. So gem value was initially, okay, so since this is false, what I'm going to do is I'm going to take, so I'm over here, right? So it will be either minimum of what is there or dp of I plus 1j. So either minimum of 1 or minimum of 2 plus 1, which is 3, right? So in our case, we won't update it. So this is going to be 1 itself, right? Now, since the school is true, this will be 0. Now again, the store distance will either be this or 0 plus 1, which in our case will be 1. Does that make sense? Yeah. So now the answer, the dp of I dp of im for this case will become 1, because the maximum distance is 1.
Yep.
Right. So in the end, I will return the minimum of all of these dpims, right? So minimum of 2, 1, like that.
Yeah.
Right. So in this, so again coming over here, so here gem value is true, so it will be 0, and this is also true, so it will be 0. Since this is false, here it was infinity, so it will be minimum of 1 plus 1, which is 2. So answer will be 2 over here. Make sense?
Yep, makes sense.
1 second, just.
Yeah, no problem. Take your time.
Yeah. Now 0, so this is okay. Now either the distance will be 1 or max of 0 plus 1, so it doesn't matter. So this is going to be 1. So either infinity or 2 plus 1, which is 3. So here it will be 3. Again over here, if we come, so the gem distance over here was infinity. So here it will be 0 plus 1, which is 1. Here it is true, so it will be 0. So 4, and max of all of these 4. Right. So now I have to return minimum of 4, 3, 2, 1, 2, which will be 1. So this will be our answer.
Gotcha. And just to be clear, can you remind me the reason that when you go from right to left, you skip the final index? What's the logic behind that?
Because essentially I want to see the distances from the right? So this is the rightmost element. So like there is no element on the right. So there's like when we calculated from left to right, I did not calculate for 0th, right? So I already did some pre-calculation. It is similar to that. But since some calculation is already done over here, I don't have to do it separately, just that.
Yep, makes sense. Okay, makes sense. And so I guess as a final few things for the finding the minimum index, just walk me through out loud what you would do.
Yeah, so
You
here just I can just keep a result, right? And here every time I calculate dp of im, so I don't have to update the result in the first iteration, since anyway I'm going to do it again, right? So my result will be equal to minimum of result and dp of im. So this is when I'm going back, when I in my iteration from right to left, when I'm going back, I calculate these values. So okay, when there is just one element, this will not work, because in that case I am not calculating dp of im at all. This will be at least when there will be at least two elements, right? So when there is just one element, n equal to 1, I will have to return the so for this one I should calculate, I haven't done dp of im for the first one, right? So dp of im will be equal to essentially this, right? So my resultant here I can just store result equal to dp of im. So this is just for the case when there will be one element.
And plus, I mean, in the case when there's one element, I guess I could have specified that maybe the input just always has two elements rather than one, because there's only one apartment that you could go to, so it doesn't really make sense. But good that you caught that. Could you walk me through the time and space complexity of this algorithm?
Yes. So for each block, I am going through all the requirements, right? So if this is, so there were n blocks and m requirements, so the time complexity will be order of nm over there also and over here also. So it is order of 2 into nm, which is essentially order of nm, and the space complexity is also order of nm, since I am storing the requirements for all of them.
Yep. Okay. Great. And this is better than the brute force solution that you alluded to at the very beginning. Although I think at the beginning you were doing the minimal distance of the sum, but you were still alluding to a brute force solution, I think.
Yes. Were you expecting a better complexity solution, or is this okay?
Nope, this is great. Just maybe as a final thing, because we still have roughly 10 minutes here, but as a final thing, just out of curiosity, how would you, if you had to, do you see ways that you would improve this code, maybe from a code perspective? Because here we sort of did it in pseudocode, part real code, part pseudocode, but how would you do this if you had to write the function signatures and things like that?
So obviously I have not taken correct naming conventions. I have just taken IEG and written not at all professional way. So the naming conventions I should definitely change. I have taken vector of vector and I've called it DP, which is when a third person is reading, it doesn't really make sense, right? So maybe I could have named it requirements distances, and similarly, naming conventions for ING, I could have definitely done better and written it in a better way.
Okay, cool. Well, listen, Keerti, I think this is great. Super quick commentary. As you're about to see, in the last 10 minutes of the interview, we did a second coding interview question. And in hindsight, I think that was a mistake from me, the interviewer, because I had already gotten really good signal about Keerti's algorithmic skills from the first question, but I hadn't gotten the best signal from her coding ability because I didn't see her code in a sort of production grade formal quality. She even told me herself that she would have renamed certain variables and things like that. And so in hindsight, I think that instead of doing a second question where we only had 10 minutes and I knew that we weren't going to get to the coding part, so I effectively just reassessed her algorithmic skills from a conceptual point of view, I think that I would have been better off having her rewrite her code in a more production grade quality, in a more formal grade quality, and that would have given me more signal about her coding ability. That was my mistake in hindsight. Anyway, I'm telling you now, and enjoy the rest of the interview. But we still have roughly 10 minutes on the clock, Keerti, so we're going to do something completely different. We're going to switch gears. When you're at a big tech company and you're on an engineering team, you often care about, or almost always care about, the state of the code base, and specifically that all of the continuous integration tests and unit tests that are running in the code base, that they're passing, right? You don't want tests to be failing. And sometimes when engineers push code into the main repository, they break the tests. And so the tests start to fail. Right? Does that kind of make sense?
Yeah.
So what we called it on my team at Google was the build. And so the build referred to kind of like, whether the code in the main repository works correctly, compiles, all the tests are passing. And if everything worked well, we would say that the build was green. If everything didn't work well, if there was maybe like one test that failed, we would say that the build was red, or there was a build failure, okay?
Okay.
So I'm going to give you some data. It's going to be a list of lists of Booleans. So it's going to be something like, let me copy paste something for you here. It'll be something like this. So this is going to be question number 2. And what this is going to represent is each list here. You could imagine that the value at a specific index represents like 1 hour or 1 unit of time. And if there's a true, it means that the build is green. So here, the build was green. Then the build was green the next hour. Then it was green again. So everything was passing. And then suddenly, it was false, meaning it wasn't passing. It was broken. And then for another hour, it was false. Okay? Now, when this happens, an engineering team isn't happy. You want the build to be green, so you immediately want to go and fix it. And so that's why you see that immediately in the next list, it's been fixed, and it's back to true, 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 until it goes to false because it's broken. And then an engineer has to fix it, and you go back to true, 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 right?
Okay.
So we call these lists here that are effectively like the build is green, 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 and then suddenly it breaks, and then it gets fixed. We call that a build run. A build run, okay? And so what we care about as a team is to effectively like minimize the time that it takes to fix build runs, right? We don't want build runs to be false or to be broken for a long period of time, okay? So we want to minimize that. And what we care about as a data point is something that I'm going to call a green percentage, which is effectively within a build run, the percentage of time that the build was green versus broken. And so the longer or the greater the percentage, the better. Because like, for example, here in this particular array, you can see that the green percentage is 80%, meaning the build was green 80% of the time, and then it was broken for 20% of the time before it got fixed again. Okay? We want that to be as high as possible. And specifically, the algorithm that I want you to give me is I want you to take in this list of build runs, okay? And I want you to return the greatest number of consecutive build runs that have a strictly decreasing green percentage. So it basically tells us the longest like period of time during which our engineers were increasingly slow to fix broken builds. Does that make sense?
Yes. I have a question. How come the sizes of the lists are different? So, like, are we building different projects all the time, or is it because if it is the same project, shouldn't the number of hours taken to build it be same? Or
no, because you can imagine that these represent hours. So basically, it's like, okay, for a single code base, the build was green, 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 and then it broke. It broke for 2 consecutive hours. And then as soon as it got fixed again, we represent that in a separate like list. And so this is all like the same code base effectively, but here it's green, 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 then it gets broken, and then it gets fixed. So here the green percentage up here is 60%.
so
Then it's
you
80%.
care just about the percentage and not about like the number of hours or anything. So because
Doesn't matter the number of hours.
Okay. Okay. Any other thing in the question you would like to add, or was that it?
That's it. And so we want the greatest number of consecutive build runs, so consecutive lists like this, that have a strictly decreasing green percentage. And since we are running out of time, ideally just walk me through, if you can come up with an algorithm that solves this, conceptually how you would do it. You don't have to write any code for now.
Okay. Since it is supposed to be consecutive, so this essentially is a longest decreasing subarray sort of a question, right? So you have to find a subarray because it is consecutive, right? So if it didn't have to be consecutive, it could have been subsequence, and I could have just said longest decreasing subsequence, right? And we could have done like a normal dynamic programming over here. Since this is consecutive, there are subarrays, so I can just keep 2 pointers over here, and so there will be 2 pointers. One will be left pointer, one will be right pointer. So from left to right, the percentage should be strictly decreasing, or should it be less than equal to condition?
Let's do strictly decreasing.
Okay. So so I will move my right pointer and check that, okay, if it can be added to the answer, to the left to right, if it is less than the right element that we had earlier, then I'll just increase the length to 1. Otherwise, I'm going to update my left pointer and then calculate again, and I will have a resultant over here. Does that make sense, or should I just write it?
And here, when you're saying from left to right, you're saying you have 1 pointer at the left of the main big list, so that starts at here?
Yes. So the left is essentially 0, and my right is also initially 0. Okay. So what I do is that so I will keep doing that. I will basically move my right pointer, right? And then I will check that if the percentage of right is less than percentage of right minus 1, because I just moved it, right? So
gotcha. Okay, sorry to cut you off, Keerti. So I understand now. Just how are you going to be calculating the percentages?
Yeah, so that I can preprocess and keep. So the number of trues and number of falses. So it will be number of trues upon number of trues plus falses into 100, right?
And so would you do like a linear search for that?
We'll have to go through the entire list at least once, right? Because to check how many were true, how many were false. So yeah, I'll have to walk through at least once.
If I tell you that they always start as the build runs by definition are always true, and then they turn into false.
Okay. Then I can just do a lower bound, which will return me greater than or equal to, or I can just do a binary search. That is the lower bound, essentially the first place where it was false, right?
Right.
So it's sort of binary search. So I can calculate that in log n if n is the size of the list, and so log n to find the percentage. So I will have the first place where false came. So the ones before that were true, and we know the size of the list, so we can calculate the percentage.
Right, exactly. And so then the total time complexity of your algorithm would be?
So I would have to travel this entire thing once. So if say m is the maximum size of the list and n is the number of lists, so it will be order of n into log m.
Yep. Okay. Great. Listen, Keerti, we're out of time now. We're exactly at like 46 minutes.
Okay.
So I think this was great. We covered, at least conceptually, a second question. I think we can jump into the feedback now. Okay, cool. So I'm going to stop the timer. So for the feedback, I'm actually going to send you a link of the feedback form that we have on our mock interviews on Algo Expert, which is actually like very similar to the feedback that you would get at Google. So at Google, there are, here I'm basing myself off of Google, but this is very similar at most big tech companies. But at Google, usually there are these 4 main categories that you're assessed on, right? Algorithms, coding, communication, problem solving, and a few other things. But a few other things are kind of intertwined. Things like how do you handle curveballs or ambiguity, or were you was there any moment where you were like disrespectful or you didn't react well to stress or things like that. But here we're going to focus on these 4 main things. So I think that for algorithms, I would definitely give you a 4, which is the best score here, because for not only the first question but also the second question in very little time, you came up with the optimal algorithms to solve the question. You basically had no help from me in both of them, and you clearly demonstrated that you know how to work with algorithms well, right? Your dynamic programming was on point. Binary search, you got that right. So really, really well done there. Then, if you want, we'll jump down to problem solving before covering the other 2, because problem solving is often like pretty related to the algorithms. And here I would probably also give you a 4 for the problem solving. And maybe I would hesitate a tiny bit with the 3, just in the sense of like, maybe there was room for, you could have asked a tiny bit more clarifying questions, because at the beginning, you were going down the path of minimizing the sum. Yeah. But like that is, personally, I don't really find that as that big of a bad thing. I think, this was a complicated question as far as like the amount of information I gave you. And otherwise, I think you just approached the problem well. You covered, you talked about edge cases. You asked about like, what if it's an empty array? If it has one element, you even handled the case with one element. And you covered a little bit of the brute force solution at the beginning. So overall, yeah, I think that the problem solving was really on point there too. So I would give you probably a 4 there. Quick commentary. So we're about to jump into the coding ability section of the feedback. And as I said in the first commentary in the middle of the interview, I think that in hindsight, I made a mistake as the interviewer. I didn't get quite as much coding ability signal as I would have liked from Keerti and from this interview. You'll see that in the feedback here, I kind of err on the nicer side. I'm a little bit nicer to Keerti than I could have been. And ultimately, in a real interview, what I would have done here is I would have left a note for the hiring committee telling them that I didn't get quite the amount of signal about Keerti's coding ability as I would have liked to have gotten, and for them to just keep that in mind. Then, if we jump into the coding, so for the coding, you notice that at the end I asked you kind of like what you would do to improve the code, and I think that's important to ask as an interviewer, just because I know that sometimes, especially depending on your background and like when you're under stress in the interview, especially on a Google Doc, you write, you go with fast variable names like DP, especially if you come from a competitive programming background, DP, DFS. But clearly, like you said it yourself, you would have likely, cleaned up the code a little bit, renamed it more properly. You also asked me about the pre-processing and all that stuff, which I'm very confident you could do. So for the coding, I would go with anywhere between a 3 and a 4. I don't think that there was anything really like a red flag. And the one thing that maybe would have made me think it was a red flag is if you didn't tell me anything of how it could have been improved. If you didn't realize that things like DP aren't amazing as naming conventions and things like that. But otherwise, I think that was fine. I guess maybe one point of improvement that I would maybe have given for coding might be subjective, but I think you did it well, because I think your algorithm probably runs perfectly, but you stuffed a lot of stuff in all of your for loops. Like, for instance, keeping track of the final minimum index distance, the result, I think, that could have been an entirely like separate function. You could have also separated some of the like maximums that you're keeping track of in a separate function. But like, I don't know, it worked well for you. So overall here, I think I would probably give between a 3 and a 4.
Okay. That I would say is subjective. I should have probably mentioned it, because some interviewers might probably expect that, why to increase the complexity by making another function and, another call, and it's just an overhead. So, but yeah, it becomes cleaner like that. So it's a trade-off basically, which I should have mentioned probably, that I could have coded it like that as well.
Yeah, and I guess if you want to take one piece of feedback that might help you in any future interviews you do, it would be that like maybe you can at least tell your interviewer you're thinking that you could do it in two different ways. You feel comfortable with doing it all, in a single function or in a single for loop, but maybe it would be, easier for readability purposes or for, logic grokking purposes to split it up into more different logical units.
Yeah, got it.
Yeah, because I guess the last point I'll say here is just, in general, but this is kind of subjective, but for me, I find it very helpful to kind of think of how I'm going to solve the problem in, let's say 3 different logical steps. So here it would be number 1, left to right, number 2, right to left, and then number 3, maybe, I guess in the right to left with that approach, you always update things, there, so that makes sense. But then I would have separated out that final step of finding the minimum index in a separate kind of logical unit. But again, I think overall, you did great there, and I think we're on the same page given what you just said right now.
Okay.
The final thing is communication. For communication, I would probably give between a 3 and a 2, or like 2.5 and 3. Okay. I don't think I would give a 2 because 2 is a bit harsh. I think I would give a 3. The only reservation I would have about communication is just that this problem is relatively complicated, right? Even if you find the solution really quickly, which you did, so clearly the problem itself wasn't that difficult for you, it is a pretty difficult problem that has a lot of little things to keep in mind, right? You're keeping track of the minimum here, but then it's the maximum, and you skip the last index and you skip the first index and all that. And I think that you could have maybe communicated a tiny bit more, and I think that some interviewers might have gotten a little bit more lost. Personally, my approach is I really want to make sure that I'm understanding what you do. So I'll stop you in the interview just to clarify, and you saw that I did that a couple times.
Yeah.
But ideally, you don't have to let your interviewer do that. Ideally, you're the one who's proactive, who's just to be clear, this is the line here that I'm using. And what you can do if you don't feel comfortable with that, or if you're this seems useless, you can ask your interviewer, which you did do, so great job there. You can ask your interviewer, are you following me here? Do you want me to go into more detail as to how I'm getting this or not? Overall, I would probably put you at the 3 for communication. To tally up, you've got a 4 in algorithms and problem solving, 3.5, let's say, in coding, 3.5 in communication. For the final score, I think I would be inclined to give a strong higher, somewhere between a higher and a strong higher. And since you have to make a decision, I'd probably give the strong higher.
Awesome. I can be hired at Google now.
But again, as far as I'm concerned, and all the viewers can see in the interview, I think you did a great job, and especially it's under pressure. How do you react to this feedback? Did you feel good about it, or?
Honestly, I thought I would get a lower score for algo problem solving because communication is my thing. So this is the first. This was a challenging thing that I have to improve on my communication, because I think, I could have communicated my approach also a little better. So, that's a good feedback for me.
Yeah, and just also one thing to keep in mind is every interviewer is a little bit different in how they assess, what one person might deem a great, amazing communication, someone else might score a tiny bit lower, but then conversely for algorithms, it might be a little bit different. I personally found that your algorithm skills really impressive. You didn't stumble at any point, and you immediately realized kind of the clever approach of the left to right and right to left thing. So
I did not expect that. Thank you so much. I'm really happy.
All right. Well, listen, Keerti, awesome job. If I were an interviewer at Google still, I would give you a strong hire, and I would hope that you did very well in your other interviews, and the hiring committee saw it the same way.
Thank you so much.
Any last words for the viewers?
I guess most of the people who come and do this mock interviews in your channel are competitive programmers. So I am not any big hi-fi competitive programmer at all. So I have a small channel where I make hard questions and explain them in a very simple way. So if viewers like that, they can just go check it out and give me feedback. I would like to improve and help them as well.
Definitely, and I'll put your channel in the description below.
Thank you so much, Clement. Thank you so much for having me. It was a pleasure.
That's going to be it for this Google coding interview. I hope that you enjoyed this Google coding interview. If you did, don't forget to smash the like button, subscribe to the channel if you haven't already. Check out the other Google coding interviews that we did on Keerti's channel in the description and comments below. Otherwise, don't forget to follow me on Twitter and LinkedIn if you enjoy short form written content, Instagram if you like pictures, and otherwise I will see you in the next video.